So the problem here, linear SVC, support vector classifier machine learning SVM, example with Python. So this would be converted into a Python program. We will find it out how much drawing you are able to get from this Python. So before going to this program, already we discussed about support vector machines. It was developed in 1960s and refined in the 1990s. It became most popular in the machine learning field because SVM is the most powerful as compared to other algorithms. This SVM is a supervised machine learning algorithm. That's why training data is available to train the model. And also SVM uses classification algorithm to classify a two-group problem, and it focuses on decision boundary and support vectors. Now, in this problem, to go ahead with this one, so we need to have to import some of the packages. Now, import numpy as np, import matplotlib.pyplot as plt, and from matplotlib import style. So these three packages are required to be get to work with this SVMCs. And this is a sample here. How does it draw a diagram is? To get this one is, we are taking here randomly 50 numbers we are generating and putting in an array. So data is equal to np.random number of 50. And you use the solarized light. You use the solarized light as a style to get this output. And we have set plt.plot of data. And it shows the output here now in like this fashion. So 50 random numbers are generated and it's showing for you. So now, what is this example is, above example is to get such type of a graph. Now we'll go to actual program is. The program is about here now how to do the SVM using the Python is. The most applicable machine learning algorithm for our problem is a linear one. So we are taking the linear kernel function in doing of this particular program is. Before hopping into linear SVC with our data, so how very simple example that should solidarity your understanding of working with linear SVC. So the objective of linear SVC is to fit to the data you provide, returning the best fit hyperplane that divides or categorizes our data is. So we are supposed to identify the hyperplane, then margins. These are two important things to be done. From there, after getting the hyperplane, we can then feed some features to your classifier to see what the predicted class is. This makes this specific algorithm rather suitable for our users, though we can use this for many situations. So we'll draw first of all the hyperplane, the margin lines, then we'll predict the data belongs to which class, a positive one and negative one. The first one is import numpy as np, as I said in the previous example, and here you're using called ggplot. So stands for plot line. Plot line, we're using that. And from scalar, import SVM. This is the important one to work with the support vector machines. So matplotlib here is not truly necessary for linear SVC. The reason why we are using it here for eventual data visualization. Typically, we won't be able to visualize as many dimensions as we learn have features, but it's worth visualizing at least once to understand how linear SVC works. Other than visualizing packages we are using, we will just need to import SVM from sklearn and numpy for array conversion. Now consider we have two features to consider. The features will be visualized as axis on our graph. So something like x is equal to 1, 5, 1.5, 8, 1, 9, and y is equal to 2, 8, 1.8, 8, 0.6, 11. Then we can graph this data using the plt.scatter xy, plt.show. So the results you can find it in the your graph. So it's showing the two-dimensional graph, the 2D graph you're able to get. So if we had three features, it could be a 3D graph. So the 3D graph would be a little more challenging for us to visualize the group and divide, but still we can do it. The problem occurs when we have 4 features or 4,000 features. Now you can start to understand the power of machine learning. Seeing and analyzing a number of dimensions is very easy in the Pythonese. With that in mind, we are going to go ahead and continue with our 2-feature example. Now, in order to feed data into our machine learning algorithm, we first need to compile an array of the features rather than having x and y coordinate values. So we will see the features list below stored in capital X variable. Let's translate our x and y coordinates into an array that is compiled of the x and y coordinates, where x is a feature and y is also a feature. We'll convert the entire data into array, 2-dimensional arrays. The entire thing, all of them are converted. So how many do you have? There are 6 features are there. All of them converted to like this here. Instead of features, 6 instances we have. 6 instances we have. So y is equal to, we said it's called 0, 1, 0, 1, 0, 1. So these are called targets. So these are labels, sometimes referred as targets. So we are going to use either 0 or 1. So just by looking at our data set, we can see we have coordinate pairs that we are low numbers and coordinate pairs that are high numbers. So we have then assigned 0 to the lower coordinate and pairs 1 to the higher number features are. You can find it out here now. So low ones we have 1, 0, higher ones we have 1 values. So this is 1, 0, 5 is higher 1, 1.5 low 0, 8 higher 1, 1, 0, and 9, 1. You can find it like this. Moving it along, now we are going to define our classifier. We said C is equal to 1.0 and the kernel function is linear. Our kernel is going to be linear and C is equal to 1.0. So C is a valuation of how badly you want to properly classify or fit everything. The machine learning field is relatively new and experimental. There exist many debate about the value of C. So just one C is equal to 1.0 is a default parameters. Now CLF dot fit x comma y values. Now, so skikit learn is a older version has deprecated this method. By version 0.19, this code will cause an error because it needs a numpy array and reshape. To see an example of converting to a numpy array reshaping, check out this k nearest neighbors tutorial available. There it is possible you can understand. Now we can do this one without knowing this particular point. It is possible for us to understand this one is. Learning is done. It should be nearly instant since we have such a small data set. Now you can predict the test. Let's print the prediction is. So print the CLF dot predict 0.58, 0.76. So predicts a 0 since a lower coordinate pair is. So lower coordinate pair will assume that it's a lower coordinate pair. Sure enough, the prediction is classified of 0. Next, what you do now, we'll go for higher one, 10.58, 10.76. Again, we have theoretically correct answer 1 as a classification. This was blind prediction is. Though it was really test as well, since we know what the hopeful target was. Now to visualize your data is, we have to use all this one is. So A is equal, so the weight, all the values are stored in the weight. So all the weight values is an array, and here now weight 0, weight 1, and line space 0, 12, and intercept the values. Okay, here dot intercept 0 divided by W of 1, weight of 1, and label you could not weighted division and scattered one. So values will be taken and it shows the values for you. SVM will get it. So do this exercise and see the observe the results. Thank you.